Welcome to the fourth episode of our Gods Showcase series. In the previous episode, we added a checkpoint system to our game. When the player reaches a checkpoint, the current state of the game gets saved to a JSON file by the Gods Save Slot system. The file contains the player's health and position as well as the amount of collected currency. Additionally, we save the position of the remaining coins, diamonds, and emeralds in the scene. In this fourth episode, we will use the save slot system again to load in the data of the created JSON file, to restore our game state to reflect the save file. To do so, our save slot will first load in the data from the save file, and will then forward this data to our observable data structures. After our observable variables and lists got updated with the new data, they will invoke an OnSaveLoaded event, which we can use to react accordingly and change our scene to reflect the new data. All right, let's start implementing this behavior. We want to load a save file when the player died to reset the game back to the state at the last checkpoint. So, the first thing we will want to add is an event which we can raise once the player's health points got decreased to 0. To do that, let's open the player health script and add a new void game event field. And when we take damage, we check if the current health value is 0. If so, we raise the player died event. Okay, now we also need to create this event object by selecting the player object and clicking the Create button on the player died event. Make sure we place the asset in a fitting folder and rename it to Player Died Event. Very well. We now need an object which listens for this event to reload the save file if there is one. We will use the save slot handler for this. So, let's select that object and add an additional void game event listener component. The raising event is our freshly created player died event, and in the response event, we add the load data method of the save slot handler. To test this, let's first increase the damage of the thorns a little bit so the player object will die more quickly. And now when we enter play mode and bring our health down to 0, we should see a message in the console coming from the save slot handler. When we select our observable variables and lists, we should also see that the current values and the current lists got updated. Very well. Additionally, the OnSaveLoaded events on our variables and lists got raised after loading in the saved data. Currently, we don't have any objects which react to these events, so we did not notice anything in our scene, but we will modify our objects now to reflect these changes in data. Let's start with our currency texts by selecting the coin text object. The Gods Bind Text Mesh Pro component is responsible for displaying the current amount of collected coins. Currently, it only updates the text when the onValueChanged event of the referenced variable is called. After loading a save file, the current value of the referenced variable changed, but we need to tell this component to refresh its visuals when this happens. We can easily do so by clicking on the disk symbol beneath the variable field. Doing so gives us access to the OnSaveLoaded event. Here, we just need to add an entry and select the Update Displayed Value method of this component. Now, after a save slot which references this variable loads a save file, this object will properly react by updating the displayed text. Great, let's quickly do this for our other currency texts as well. And then test our new behavior. First, I collect some coins and diamonds, and then by reaching the checkpoint, these values get saved into a save file. Now let's collect some more coins and diamonds to raise the displayed texts. Then I will take damage to raise the player died event and to reload the just created save file. Our text will now update once the save file got loaded, and they do. Awesome. Now the remaining values we need to restore correctly are the player health, the player position, and the collectibles in our scene. Let's start with the player health real quick. The only place we need to update is our health slider. Select it and inactivate the disk symbol of the player health variable. Then drag in the Gods Bind slider component and select the Update Slider Value method. And that's it. Now for the player position. Remember, we already have a player position variable. When we trigger a checkpoint, this variable gets updated and stores the position of the checkpoint. Now when a save gets loaded, we need to set the player to the stored position. We will do this through the player movement script. So, let's open that script and add a new vector3 reference field called checkpoint position. And then add a method like resetPlayerPosition, in which we set the player position to the position of the checkpoint. Note, since the SaveLoaded event of the observable variable has a vector3 as parameter, We could also write reset player position with a vector3 as parameter and use that parameter to set the position instead of using the referenced variable. Okay, with that done, let's compile and then drag in the player position variable, activate the disk symbol, and select our new method to be called when a save gets loaded. We can either select the dynamic vector3 method or our static reset player position method. Let's test this. First, let's activate a checkpoint and then take damage until the player object dies. Then, the player object will get placed at the last checkpoint. Nice. And lastly, for our collectible objects. To restore them to how they were when we reached the checkpoint, a possible approach is to destroy all of them and then respawn them on the positions they had when the checkpoint was activated. For this, I already created a script called Saved Data Spawner. This holds a reference to the prefab, a coin, a diamond, or an emerald, and references to the object positions and the spawned objects. Remember, our collectibles have a component called Savable Object List. Using this script, they add themselves to these lists when they spawn, and they remove themselves from them when they get destroyed. Alright, with that in mind, let's head back to the spawner. When the positions get loaded from a save file, we want to call the handleSaveLoaded method to destroy all existing objects to then spawn objects on the saved positions. Note, we manage our own internal vector3 list to spawn the objects, as the referenced list would be empty after we destroy all existing coins, diamonds, or emeralds. Okay, let's start respawning our currency objects. First, create a new game object and call it Collectible Spawner and attach a Saved Data Spawner to it. Then we need to choose our prefab. Let's start with a collectible coin. Then we need to reference the lists which hold our data, the coin positions and the coin objects. Then we activate the Save Disk symbol on the Positions field and add the handleSaveLoaded method as a response. And that's it. But we also need to do this for our other collectibles as well, so let me fast forward this video while I do this. When we test this now, everything should work as expected. We can take some damage and collect some coins and diamonds. Then when we reach the checkpoint, our game state gets saved. We can collect some more diamonds and coins, and when we die, we will get set back to the checkpoint, and the coins and diamonds we collected in the meantime should reappear. Awesome. Of course, for a fully fledged game, we would have to do some proper adjustments, like playing a death animation before reloading the save file, or restarting the scene if a save file is not available. But we can see that God's globally observable data structures provide some very useful systems for saving and restoring a save file. Additionally, using God's, we managed to create this scene with zero dependencies between our objects. We could remove any of our objects, like our health slider, currency text, and even our player object. And the rest of the scene would still proceed to work without throwing errors. I hope you can see how making our game objects more modular can benefit our development process. Adding and removing features becomes much easier when our objects can stand on their own. And with that, we are reaching the end of this series for now. To recap, in the first episode, we discovered how we can use observable variables to decouple our game objects by only referencing the values we actually need. In the second episode, we added the player health and collectible currencies, and we made use of the event systems on our observable variables to update the visuals of these objects only when necessary. In the third episode, we added a checkpoint system using observable game events, and we stored the positions of our collectibles in observable lists. Then we created a God save slot and used it to save our data to a JSON file. Now in this fourth episode, we used the save slot system again to load our saved data and restore the game state back to when the player reached a checkpoint. We did all this while keeping our objects decoupled and modular. You're welcome to share your thoughts on this tool in the comments section or in the linked Unity forum thread. I'm confident many of you will find innovative ways to use it, and I'm eager to see the systems you create with God's globally observable data structures.